Okay, so we're going to go ahead and take a look at doing some of the problems from Chapter 3, Section 2. And we did several of the problems in class. Really, the problems that I want you to focus on for the quiz are problems 19, problems 20, 21, 22, 22, 23, 24, and 25. If you know how to do all of those, that's going to be good for the test. All the problems are going to be represented by these here. No conversions. I'm not going to ask you to convert things to angstroms or millivolts or anything, or electrovolts. But there will be a lot of problems on the test because a lot of these can go pretty quickly. They don't take very long to punch out. So in order to have some separation on this test, unlike previous tests, I'm probably going to have a lot of problems, maybe to the tune of 25 problems. Now that sounds like a lot, and that's like 2 minutes a problem. I understand that. But what we're going to do on the back end is going to scale. Okay, so after we grade the quiz, or after I grade the quiz, we'll take a look at how everybody performs, and so then there'll be a nice bell curve afterwards, because there will be a scale. So of course, the center of scale is here, and B's and A's and D's and those people that don't know what they're doing down here. So, any rate, that's kind of how it's going to go, and I just wanted to let you know that. So, let's go back here to take a look at how to do a couple of these problems. Now, I'm not going to focus on the ones that we did in class because we already did them in class. So, let's take a look at a couple of the other ones that you may have tried at home over the last couple days, and practice those so that way you may have some practice. So really here we're going to take a look at problems number 20 and problem number 22, because like I said, we did 19, 21, 23, 24, and 25 in class already, but this was just going to be a nice little refresher in case you practiced a couple of these problems. So number 20 says, using the Bohr model, determine the lowest possible energy in joules for the electron and the lithium ion. So I've got the lithium ion, and what I know about the lithium ion is that it's atomic number 3. So I now have a Z of 3. And it says lowest possible energy state. So if it's the lowest possible energy state, we're talking about the ground state. So I know my N is going to be 1. Now, I'm writing all this down, not that I'm necessarily going to use it, but because I actually want to see what kind of information I know going into the problem. Now, there's really only 3 formulas you need to keep track of, and I'm going to write these down here. You have the change in energy is going to be equal to K times 1 over N squared 1 minus 1 over N squared 2, something like that, or 2, 1. I forget which it is off the top of my head. But that basic formula, and then you have E is equal to negative K, Z squared over N squared, and then you're going to have the Bohr radius. R is equal to N squared, and then you have the Bohr radius constant, which is alpha naught over Z. Okay, and when you look at these things, you see you got Z here, you got N squared, but this here is indicating that you want a radius, and we're not looking for a radius in this problem. We're looking for energy. So we're going to be looking at one of these 2 formulas here, right? And so I don't have 2 states. It doesn't tell me 2 n values in this problem. This would be if like I had n of 5, n1 is 5. In other words, it's starting at 5 and then it's going to 2. And in this case, I would actually have 2 n values where it starts and where it ends, and so therefore I'd be subtracting them and I get my answer. Now here you're actually only dealing with a 1 n state, and you've got a k value and you've got a z value. Now we know the value for k because that's a constant, so this is in fact the logical choice to use for this problem. And so let's go ahead and plug this in. So I want the energy, and this is going to be the energy of N. We could actually write that in the formula here. The energy of N is equal to negative K Z squared over N squared. So I start plugging these in. The value for K is 2.179 times 10 to the negative 18th joules. So that's negative K, there's my K value, and it's negative. And then Z squared, we said it's 3, so 3 squared is going to be 9. So I'm just going to write 9 in there to save some time. And I'm going to divide that by n squared. N squared is 1. 1 squared is 1. So simply this is just going to be a case of multiplying negative 2.179 times 10 to the negative 18th times 9. And so when you do this in this problem, you're going to get a value like negative 1.961 times 10 to the negative 17th joules. Now, what I'm going to have you do for this test is I'm going to have you put everything into 4 sig figs. Every answer is going to be in 4 sig figs. The reason is you're going to get values for z, you're going to get values for n, and these are all going to be single-digit values, which kind of destroys the flavor of the accuracy of what we're trying to calculate. So we're just going to make it a standard 4 sig figs for every answer, and also remember your labels. If you don't put your labels on them, I'm going to have to take some points off because that's just sloppy, and we need to make sure we have our labels. Okay, so let's go ahead and do the next problem, and the next problem is, I said 22. Let's take a look at 22. Ooh. Pointer options, erase all ink on slide. 22. I hit the little button on the underside of my pen and it knocks me off the screen. Okay, so here it says using the Bohr model, determine the energy of an electron with n is equal to 6 in a hydrogen atom. So hydrogen atom is atomic number 1. So I know my Z is 1. So again, this is going to be a very similar similar problem. Oops, did it again. Going to be a very similar problem, and we're going to set it up just like the last one. So 22. So we have E is equal to negative K Z squared over N squared. In this case, it's hydrogen, so Z is equal to 1, and N, they told you, was 6. So energy is going to be equal to negative K, 2.179 times 10 to the negative 18th joules, times Z squared. In this case, Z is 1, so it's going to be 1 squared, or 1, over N squared. N is 6, so 6 squared is 36. So simply in this problem, you can see you're just going to have the energy is equal to negative 2.179 times 10 to the negative 18th divided by 36. And when you calculate that out, you get negative 6.053 times 10 to the negative 20th joules. Okay, and very simple problem. If you take a look at problem number 24, remember we did that one in class. In that one, you're solving for n squared. Now remember, in all these problems, you need to be able to solve for whatever variable you don't know. So if you had something that was squared and you had some value, I don't know, I'll make up a number, 23.615 times 10 to the negative 18th, and it was squared, I would need to take the square root of that. So let me get rid of that thing there. Boop. All right, so we need to take the square root of that and square root of this to get the value for actually for n. So you would punch that in the calculator, take the square root of that, or hit square root and punch it in the calculator, depending on how your calculator operates, and then that answer would be your final answer. And remember, that was one of the differences with number 24 when we did it in class from some of the other options. And then finally, doing a Bohr radius. Let's do one of those in case, just to refresh, and that way you can kind of remember how to do that. So 25, again, we did this in class, but just to do 25 real quick. It says, what is the radius? So if it says the radius, you know automatically you're going to use that formula, n squared Bohr constant, or Bohr radius constant, divided by z. And this value here has a particular value as well. So here, what is the radius of the orbital of an electron with n is equal to 8? N is equal to 8, and a hydrogen atom. So you're looking at hydrogen again, so my z is going to be 1, and so you just plug them in. R is equal to n squared. 8 squared is 64. Now alpha naught, which is the Bohr radius constant, is, and I don't have it here on my sheet, I forget what it is, but you would plug that in here. Okay, you'd have to look it up. I don't have it in front of me. And then z is 1. Okay, so then once you put that number in here, because it's a constant, that's not going to change, you would multiply this times 64 and divide it by 1, which of course is going to be the same as dividing alpha naught by 64, and that's going to be equal to your radius. So that's going to be a nice, quick, easy problem to do as well. Again, be careful. Make sure you keep 4 sig figs in your answer. Make sure you pay attention to your labels. Okay, because I know a lot of people are going to do really well on this test, which I want, but you know, I'm going to put a number of problems on here because they go pretty quick, and that way I can keep them to only like 2.5 points each, rather than having each one be like 5 points each or something like that, and then you screw it up, and then you're down a whole letter grade on one problem. So this will be better, and then it'll help separate those that know what they're doing from those that don't know what they're doing. So we'll have a nice little bell curve afterwards. And if the grades are really bad, we'll scale it. I don't expect them to be too bad. I expect them actually to be very good on this quiz. So we'd look for a nice distribution. A little hat there. There we go, a little hat with a feather. Okay, that's it. Any questions, let me know. Come by, see me in the morning. And but I think that along with your notes from class on Friday should kind of cover the problems. They were relatively easy. All right, thanks, and we'll see you tomorrow. Bye-bye.